Hello and welcome back to PA Academy. So this is the example 1 under the video series SuperMesh. So if you missed the previous part of this video, kindly check the description of this video. You'll find a link to the example 1 where I did more like an introduction into SuperMesh. So now let's look at this example. It says find the current in the 2 ohm resistor. Okay, sorry, not 2 but 7. It's supposed to be 7. So this is 7. Alright, so this is 7. So this means current in the set. That means in this particular resistor, we should find the current that is flowing through this 7 ohm resistor. Now, this is a typical question that you come across. And now, if you look at the way the question is being written, said find the current in the 7 ohm resistor using mesh analysis. Now, you can see the question did not tell you that it is super mesh, and that is another thing you need to pay attention to. Questions that have to do with mesh analysis will not tell you when it is super mesh. But when you come across the question, you should be able to spot or know immediately that, oh, this question is what is super mesh. Also note this, it says using mesh analysis. Now if you watch the previous part, this is the same diagram I used, but now I'm using giving it some numbers so that we can use the concept I explained in the previous video. Now this same circuit, we can solve this circuit using nodal analysis, but the question wants us to use mesh analysis. So that's what you need to pay attention to in questions. You have to pay attention to the method you are asked to use. So if you solve this question using method different from what you are asked to do, the person can mark you wrong. So now let's get started. So the first thing you have to do is we look at our diagram and then we pick our current direction. So let's do that. Alright, so let's pick a clockwise direction for this particular mesh. So let's call this I1. You know, like if you follow my video, you notice I do use a clockwise direction, but you can decide to use anti-clockwise, you still get the same answer. And this is I2, and then let's take for this particular one I3. So the next thing we have to do, since we are doing mesh analysis, is to pick what our polarities based on the direction of our current. So for our voltage source, it is constant, so this is going to be plus and this will be minus, because the longer one is positive and shorter one is negative. So that's the best way of getting to know this quick. But now let's add it to the element in it, that's the resistor. So because of I1, so this is going to be plus, minus, and then because of I2 for this particular 4 ohm resistor, this is going to be plus and then minus. Now let's look at, because of this current I3 is flowing through all the 3 resistors. So with this is going to be plus, minus, this will be plus, minus in this direction. In the direction it goes from positive to negative. So when it gets there, this is going to be plus and then this is minus. So we've successfully added polarities to all the elements we are having in the circuit. So the next thing we have to do is, since we've been able to identify that there is a super mesh, that's because there is a current source in between these 2 meshes. That's a 3 amp current source in between it. So what we are going to do now is to write our equation of the current source. So equation of the current source. So now let me draw that out. So this is what we are having. This is our current source. Now we are having 2 currents that are flowing through it. We have I2 is flowing like this. So in this direction, that means it's going like this. So let me draw it properly. So that means it's going like this, and this is I2. We also have I1 in this direction on this side, that means it's going like this. So that means I2 is flowing upward and I1 is flowing downward. So if I want to, I can just use any of these two to represent it. And then we have the value, which is 3 amperes. And from what I said, if you have to write the equation of the current source when we are dealing with a super mesh, what do? You look at the one that is in the same direction with the current source itself. You can see that the 3 amp is going upward and I2 is in the same direction with what? With the 3 amperes. So what would be the equation? So that means we are going to be having I2 minus I1 equals to what? 3 amperes. This is our equation 1. What it means that since we've been told that the current here is 3 amperes, that means by the time we subtract the value of I2 from I1 to give us 3, and that is what we're having here. So we've gotten our equation 1. So the next thing is for us to draw our super mesh. So in drawing the super mesh, let me see if my black marker is working fine. So for us to draw the super mesh, remember the super mesh is from this point here, from this node straight here. You can see this node, that is our super mesh. That means that two mesh that is sharing the same current, that is our super mesh. So we are going to draw it out. So let's draw that out. So you are going to be having something like this. Now in drawing it out, you don't need to add this current source again. You don't need to add it. Okay. So let's put in the values we are having there. So this is 5 ohms, this is 4 ohms, and then this is 8 volts plus minus, that's the current source. So now we don't need this upper part. We are still going to solve this separately. So this is the super mesh itself. Alright, so now let's add the polarities. The same polarities that we have there is what we are going to be having here. So this is plus, minus, this is plus, minus, and then plus, this is plus, minus. And all of these things are because of the current that is flowing through it. Now, this I1 is flowing through it in this direction. And that's why we are having positive to negative. Now, for this 4 ohm resistor, I2 is flowing through it in this direction. Current is I2, that's why we are having positive to negative. Exactly. Now from this I3 is also flowing through the 4 ohm resistor in this direction. It's flowing in this direction. And if you are going in clockwise, by the time it gets here, it's face here. Why when it is down, this I2 is also flowing in clockwise, but now it will be in this direction. So this is I3, and the same current I3 I3. So now we've been able to draw our super mesh. Now let's apply Kirchhoff voltage law, which is KVL. So let me write it here. Apply KVL to the super mesh above. So if you are finding value in this video, please give it a thumbs up. So in applying KVL, so let's just start from this node. So we go around the circuit and come back here. So in starting from here, from negative to positive, we have 8 volts, so that's going to be 8. So since it's from negative to positive, so once we get here, so let's just start with the I1 current. So from positive to negative, flowing, I1 is flowing from positive to negative through the 5 ohm resistor. So that's going to give us minus from positive to negative. So that's going to give us minus 5 I1. So minus 5 I1. Now what I've just done is from V is equals to IR. From V is equals to IR, I've multiplied the current, which is I1, with the resistance, which is 5 ohms. So that is it here. Now for the current I3 that is flowing through it, so from we're having the polarity to be from negative to positive, that's going to be plus 5 due to current I3. So what I've just done here, if you have watched video on that mesh analysis, I want to believe this is very clear, but I'm trying to break it down so that I can carry everyone that's watching this video, I can carry you along. So we are done with this. Now let's come here. This is from plus to minus, and then due to current I2, 4 ohm resistor, that's going to be minus 4I2 from negative to positive due to I3, so that's going to be plus 4I3. So there's nothing there again. So we come back to where we started from, and that's going to give us equals to 0. So let's simplify this and see what we are going to be having. So we are having I1 minus 5 I1. There's no other I1, so that's going to be minus 5 I1. So let's see. We're also having minus 4 I2. So I'm just doing normal math. I'm just rearranging it. So that's minus 4 I2. So we're having plus 5 I3 and then plus 4 I3. That's going to give us plus 9 I3 and then equals to, so if this 8 should come to the other side of the equals to sign, it becomes, so that equals to minus 8. So this is our equation 2. Don't forget this is our equation 1 and this is our equation 2. So if you are finding value, please give it a thumbs up, drop a comment and let me know. And if I'm speaking too fast, you can reduce the speed of the video. I think there's an option there. Alright, so now we've been able to get the equation of the current source. We've also been able to apply KVL to our super mesh. Now let's solve this mesh above. This mesh, so let's apply KVL to, let's call this mesh 3, where we are having this I3. So that means, let's say apply KVL to mesh 3. So this is the one I'm referring to as mesh 3, this particular mesh. So that's mesh 3. So if you have to apply KVL, so in applying KVL, let's start from this point to here in this direction. So let's go around. All right, so in doing that, so the first element we are coming across, the first resistor is this. So in doing that, from plus to minus, that's going to be minus 7 I3. This is 7, don't mind my writing, minus 7 I3. So if you should code, this is the next one we are coming across. So from positive to negative, for due to current I3, so that's going to be minus 4 I3. From negative to positive due to current I2, so that will be plus 4 I2. So we are done here. So let's move here. From positive to negative due to current I3, so that's going to be minus 5 I3. And then from negative to positive due to current I1, so that will be plus 5 I1 equals to 0. So now let's simplify this also and see, let's rearrange it properly. So we are having, so let me bring this 5 I1 first. Okay, which other one is I2? So this is 4 I2 plus 4 I2. Then the I3, we are having minus 7 I3 minus 4 I3 and minus 5 I3. So that should give us 16 minus 16 I3 equals to 0, and this is our equation 3. Now at this stage, we've gotten our equation 1, equation 2, and equation 3. So by the time we solve these three equations simultaneously, unfortunately my other markers I just bought seems to be dried. They are dried inside, and we are going to be working with all red, more of red. Alright, let's continue. So that means this is our equation 1, this is our equation 2, and equation 3. If you solve the three simultaneously, like I said, you are going to get I1, I2, and I3. But let me write it out properly so that from equation 1, this is, we can write this as minus I1 plus I2. We don't have I3, so we can just give it plus 0 I3 equals to 3. Then for equation 2, this is equation 2, so we have it as minus 5 I1 minus 4 I2 plus 9 I3 equals to minus 8. And then for equation 3, we have it to be 5 I1 plus 4 I2 minus 16 I3 equals to 0. So these are the three equations, and like I said, if you solve it simultaneously, you get your answer. So the reason why it is like this is that in case you want to use your calculator to get the values, so like I'll be using, can you see the screen? I hope you can see. So I'll be using my Casio. So let me just in case you don't know how to do it, I hope you can see it. So once you are with your Casio 991 like I'm having here, so your mode, so press it 3 times, you see equation, press 1. So we have 3 unknown values. You can see we have I1, I2, and I3. So unknown, so that's 3. Don't worry, I'll do a separate video showing you some of the things you can do on this calculator. So where we have A1, we are going to give it minus 1 because we are having minus I1. So it's just like there's a 1 value here. So that's 1. Where we are having, okay, sorry, it's supposed to be minus 1 because we're having minus. So you can just go back. So that's minus 1. For I2, the value is plus 1. Then for this I3 is 0. So I just put in 0 and then equals to 3. The value for D, which is 3. So once you press equals to, for all the values you put equals to, this is going to be minus 5, minus 4, 9, and then minus 8. And then this is 5, for A3 we're having 5. Okay, sorry, 5, 4, minus 16, and then 0. So with this now is our, that means x is 0.69. That x means our I1. So let me write that down. That I1 is equals to, I hope you can see it, okay, 0.698. Don't forget to always put your unit amperes. So once it brings out the values like this, you press equals to again, it will bring for y. That y represents the value for I2, which is 3.698. So let me write that. I2 is equals to 3.698 amperes, and then I3, that's 1.143 amperes. All right, so we've been able to get the value of I1, I2, and I3, but that's not where we are stopping, because that's not what we are actually looking for. The question went further, so we should look for the current that is flowing through the 7 ohm resistor. So in getting the current that is flowing through the 7 ohm resistor, remember this is the 7 ohm resistor here that we are having here. In getting the current, you have to now go back to your circuit based on the direction that we used when we started. If you look at this particular mesh, we use a clockwise direction, and in the 7 ohm resistor there is only one current that is flowing through it, and that is the I3 current. That is the only current that is flowing through it. You can see when we pick the current direction, only I3 that is flowing, compared to this 4 ohm resistor where we have 2 currents flowing through it. If you can look at this from this place, from this mesh circuit, we have I2 and I3 flowing through the 4 ohm resistor. We have I1 and I3 flowing through the 5 ohm resistor. But for the 7 ohm resistor, we only have I3 flowing. So that means the value we got for I3, which is 1.143, is the current that is flowing through the 7 ohm resistor. So you can just note it down. So let me just write it here. So this is our answer here. So because there's no space here, let me just put it here. So that means the current that is flowing through our 7 ohm resistor is what? Is I3. And we've gotten our I3 to be 1.143 amperes. 1.143 amperes. Now our answer is in positive. Our current is positive. That means the direction that we assumed at this particular point is the actual direction of the current. So that means the current is actually flowing in this direction, in this 7 ohm resistor. That means that the current is flowing in that direction. So we can also indicate it that this is the direction of the current. Don't worry, when we go to more, when we solve the in the next examples, you understand what I'm saying with this direction, where you might be having some negative current, and that is to show that when it is negative, that means the current is flowing in opposite direction. Don't worry, you understand what I'm saying. But that is it for this particular example 1. We've been able to get the current that is flowing through the 7 ohm resistor to be what? 1.143 amperes. So I want to believe you find value in this video. If you do, please give it a thumbs up. And if you have any questions, do let me know in the comment section below. I do, and I try as much as possible to answer them. You can also check out our website, paacademy.co, paacademy.co. paacademy.co. You'll find a lot of helpful information on that website. Alright, so thank you very much, and I'll see you all in example 2. We are also going to be looking at, like I said, we have like 5 examples we are going to be looking at under SuperMesh. So make sure you watch all of them, and I'll see you all in example 2. Thank you.